factorizing, right?
Yes, factorization. Our next topic will be the binomial expansion. So for binomial expansions, these are the few objectives which we'll be covering. We'll discuss them one by one. This is not something you have did it on O levels. So this is new, but these basics, for example, expand and simplify where possible. So this is a simple square or cube. We can expand these brackets, then simplify simple indices, again simplify simple indices with fractional powers. And this is going to be something new. So look at this. If we talk about Pascal's triangle and why we are doing this. Okay. For example, if you had a question like x plus 1 power 1, the answer will be x plus 1 only. If you had x plus 1 whole squared, it will be x square plus 2ab plus b square. If you had x plus 1 cube, x plus 1 whole cube. So we can do it in two ways, x plus 1 times x plus 1 whole square. We already have that answer. So x plus 1 times x square plus 2x plus 1, and the simplification will move on. So this is x cube plus 2x square plus x, then 1 with all these, x square plus 2x plus 1. And your final answer would be x cube plus 3x square plus 3x plus 1. But what happens when the power increases very much? Suppose x plus 1 power 13, then we had to have something, and which will be our binomial expansion. This is Pascal's triangle. We do have to understand this. It is part of the syllabus. It is not in GCE A levels, but it is in Pearson. And second part would be binomial expansion. This right here. This is the formula we'll be using to expand this. And because it is part of syllabus, so we'll have to cover this as well. Now, if you can see what actually Pascal's triangle is, you have to compare the number of rows with the power. You see right here, the power is 0. So we have one value. When the power is 1, we have two values. It is 1 more than the power. When the power is 2, the expressions are 3. When it is 3, the expressions are 4. When it is 4, the terms are 5. Are you getting this trend?
Can you explain it one more time?
So whatever the power is, the number of term is 1 more than that. When the power is 0, there is one term. When the power is 1, there are two terms. When the power is 2, there are three terms. Power 3, 4 terms. Power 4, then there are 5 terms. Okay. For example, if I ask a plus b power 8, how many terms will be there?
9.
9 terms, yes. Next step. In solving, so you have to understand this. When we write the first term, let us talk about this power 3. When we write the first term, do you notice there is only a and no b?
Yes, sir.
And when we write the last term, there is only b and no a. So what actually will happen? Understand this. This is a and b. Power of a will keep on decreasing and power of b will keep on increasing. See, a is 3, then a2, then a1, and then a0. Let me Make it neat. You see A is 3, then A is 2, then A is 1, and then A is 0. And if we look at B, B was 0, then 1, then 2, then 3. So A is decreasing. It started with the maximum value and kept on decreasing. And B started with the least value, which is 0, and kept on increasing. 0, 1, 2, 3. And for A, it is 3, 2, 1, 0. For example, if I say I have A, B raised to power 7, so A will start with the maximum value plus A keeps on decreasing and B keeps on increasing. Do you notice that A decreased by 1 and B increased by 1? Then A5, B2, A4, B3, A3, B4, A is decreasing and B is increasing. A square, B5, A, B6, then A. Now it is 1. So decreasing it further will make it A0 and B7. Are you getting this thing? First sequence. Now, where are these coefficients coming from? Where are these coefficients coming from? First, if you've understood this, then we'll move on to the coefficient thing. Let me know if there is any confusion in this thing. Power of A keeps on decreasing, started with maximum, and power of B keeps on increasing till it reaches maximum.
So I have a question.
G.
So in what type of situation or question are we supposed to use this expression?
It will state in the question. It will tell you that use Pascal's triangle or use binomial expansion. There won't be any confusion. It will tell you to do so. Okay. First thing was this power. Now, what is the second thing? If you notice, we do have when anything raised to power 0, it is always 1. Do you agree?
Yes, sir.
And then A plus B, when power is 1, there's no need to expand them. We can write as 1A plus 1B. Now, where are these coefficients coming from? The number, all these numbers are 1 and all these numbers are 1. So we don't have to memorize them. Second thing, the number is actually the sum of two numbers above it. If you add these two, we get 2. If you add these two, see, we get 3. If you add these two, again, we get 3. Let me change the color. If you add these two, 3 plus 1, do you get 4? Look at this, 3 plus 3. 3 plus 3, do you get 6? I'm clearing this and we're talking about this again. We add these two, do we get 2? 1 plus 1, 2. Then we add these two, 1 plus 2, we get 3. Then we add these two, 2 plus 1, we get 3. And this color, when we add these two, so number between them is 6. Changing the color again, when we add these two, 3 plus 1, we get 4. Are you getting it? You don't have to memorize it at this stage. Just understand.
So later on, we'll have to memorize the outcomes of Pascal's triangle.
No. Let me show you. It is very easy. It is very easy. So if you have this, suppose the power is unknown. Suppose the power is unknown. If I write the first term as 1, because it is raised to power 0. Second is power 1. I would write A plus B, right? And now just keep comparing. This is 1, this is 1. So when I increase it to 2, I know that it will be A square, as we discussed that the power of A keeps on decreasing and power of B keeps on increasing. Remember, if we started with if we started with like a plus b power 7, it will be a7 and b nothing. Then it will be a6, b1, a5, b2. Someone tell me the next value.
4b3.
A4, B3.
Shabash, a4, b3. Then a3, b4. A is decreasing and b is increasing. A2, b5, a1, b6. Then we have no a but b7. One thing is missing, that is the coefficient. What should come over here? What is the number which should come over here? Pascal's triangle, it won't ask you for higher powers, only for small powers, but just to understand the sequence, we can discuss this. Let me bring this in center. If it is a plus b raised to the power 0, anything raised to power 0 is 1. If it is a plus b raised to power 1, we know that we can write 1a plus 1b, right? If we write a plus b whole squared, now following Pascal's triangle, we know that the first number is a, so it should start with the highest power, a square. Then a reduces and b increases. Then again a reduces and b increases. Is this thing following the sequence? And where is it coming from? The first value is always 1, the last value is always 1, the number, the coefficient. And what should be the coefficient of a and b? When you add these two, 1 plus 1, what do you get?
2.
2. So this is 2. Now I'm going to write the third line. If I have a plus b whole cube, we know the first number is always 1 and a starts with the maximum power. The last number is always 1 and b ends with the maximum power. Do we have agreement here? With the first and last.
Yes, sir.
And now the power of a will keep on decreasing. So this will become a2 and 1b. Next part, power of a will keep on decreasing. This is a and b2. And in the last term, c, a disappeared and b is cube. Now add these two. What do you get? 1 plus 2 is?
I don't know, sir.
Stay unmuted. 1 plus 2 is?
Can we use our calculators?
1 plus 2.
I think it's 5.
Yes,
3.
that is 3. Now 2 plus 1 is?
3.
3.
3. The number below is the sum of the numbers, 2 numbers above it. Now I'm going to write the fourth sequence. A plus b power 4. Before I write, I know the maximum power of a will be 4. And at the end, the maximum power of b will be 4. And we have a genius working on mobile. Or are you taking class over there? Okay. That was ensured, I guess. A plus b power 4. So first number is 1a4. Now a will keep on decreasing. That is a cube and b comes in. Then a decreases again, a square and b increases. A decreases again and b increases. And in the last part, a disappears and b 4. Now we have to write the coefficients. First and last coefficient is always 1. Add these two. 3 plus 1 is 4. Then add these two. 3 plus 3 is 6. Then add these two. 3 plus 1 is 4. This is how you solve Pascal's triangle. Writing a and b is easy. Now let us do it quick. A plus b power 5. It starts with 5, 1a, 5. It ends at 5, 1b, 5. In between, the power of A decreases. So A4B1. Then we have A3B2. Then we have A2B3. Then we have AB4. Then we have A0B5. Now I have to write the number. So 1 plus 4 is 5. Then 4 plus 6 is 10. This positive sign lies outside this. This is 10. Then 6 plus 4 is again 10. And the last one, 4 plus 1 is 5. Yes, Mohammed.
Why didn't we learn this in IGCSE? I feel like it would have made expanding brackets easier.
Actually, it wasn't required there. Your syllabus ended at raised to power 3. That is why they didn't make you learn this.
Oh,
Here we'll move on. The Pascal's triangle, we discuss it up to 5. Again, the examiner will ask you till 3 or very basic questions. Next thing. What is the total power? Total power. If I say I have x power 4 multiplied by x power 5, may I say my total power is 9?
yes.
If I say a power 2 and b power 3, if I tell you my total power is 5, that will actually tell you what was the power on the main question. So see, do I get 5 here, max power? And in this second term, this is 4 plus 1 again 5. In this 3 plus 2 again 5. In this 2 plus 3 again 5. In this is 1. 1 plus 4 is 5. Last part is 5. So this 5 tells you that the power was 5. And count 1, 2, 3, 4, 5, 6. The terms are always one more than the power. So select this 3. Now see 3. Sum of these two is 3. Sum of these two is 3. Sum of these two is 3. And the power is 3. How many terms are there? Always one more. 1, 2, 3, 4. Now let us come to the question and you'll know what is asked related to Pascal's theorem. Where are the controls? This is it. Okay, look at this question. It says state the row of Pascal triangle that would give the coefficient of each expansion. Now this is 3. So this 3 means there will be 4 terms and it will be the 4th row. How it will be the 4th row? First power is 0, then 1, then 2, then 3. So x plus 1 power 0, x plus y power 1, x plus y power 2, x plus y power 3. So it will be the 4th row, 1, 2, 3, 4. Power plus 1 is row and there will be 4 terms. First will be x cube, second will be x keeps on reducing and y keeps on increasing, and these will be the terms. And first and last is always 1, and obviously if we will complete Pascal's triangle, we will know what the coefficients of these two are. Look at this. This is 15. Now it won't ask you to complete the Pascal's triangle, but it will ask you about the basic things. State how many rows. So these are 4 rows. These are 16 rows. These are n plus 1 rows. And these are n plus 5 rows. One more than the original. Okay. To understand Pascal's triangle, you have to practice this. Write down the expansion. And Mohammed, I remember. So we'll do few questions and not only one example. So let us pick the positive ones first only. This is x plus y power 4. X plus y power 4. So x plus y power 4. We know that we have to start from 0, then 1, then 2, then 3, then 4. When we start from 0, anything raised power 0 is 1. Then from 1, this will be x plus y only. Then 2, first and last are always 1. Then 2, we have 1x square. Last one is again 1y square. And when we move in between, x reduces, y increases. And 1 plus 1 is 2. So this is the third row. Then for power 3, it is 1x cube plus x reduces, y increases, plus x reduces, y increases, plus x reduces, and y increases. Now the coefficient is 1 plus 2 is 3, 2 plus 1 is 3, and first and last are always 1. For the fourth line, this is 1x4, last is 1y4. Now this is 1 plus 3, 2 will be 4, and x reduces, y increases, plus 3 plus 3 is 6. So x reduces, y increases, plus 3 plus 1 is 4. X reduces, y increases, and this is your final answer for x plus y power 4, this using Pascal's triangle. Another example. Let's choose this a plus 2 power 5. A plus 2 power 5. Now a plus 2 power 5. Now power 5 would mean 0, 1, 2, 3, 4, 5. So anything raised to power 0 is 1. Then for the first line, it is a and 2. Now in this case, these are not a, b or x, y. This is a number, and number part, anything we can always solve it. So this is a plus b. Now the first term, when the power is 2, this is 1a square. And second, a reduces, this is 1, and b increases, this adds in, plus 2 squared. We can always simplify it, but we are interested in the last line. So we are carrying it using Pascal's triangle and simplify the last line only. So third is 1a cube. It starts with maximum power. A keeps on reducing. So this becomes a square and 2 power 1 plus a and 2 power 2 plus now the a disappears and 2 power 3. So when you come at the fourth line, this is 1a cube plus, 1a4. So it reduces, it becomes a cube 2 power 1 plus a2 2 power 2 plus a1 2 power 3 plus 2 power 4. And the last line. Last line is
What about
1.
the coefficients, sir?
We are writing it. I'm coming to them.
Okay.
So 1a5, then a reduce.
Assalamu alaikum, sir.
Alaikum assalam. This is
So
80a squared plus
so you're not
2 4
screen
times.
sharing.
You're not screen sharing.
Where did it go? Did I lose connection?
Yes, sir.
Okay. Let me explain this again. Now we are actually multiplying the given numbers. So this is simply 1a5. So a5. Now 5 2 times is 10. Then this was 10 4 times 40. This was 10 times 8 2 cube is 8, 8 into 10, 80. 2 power 4 is 16. 16 into 5 is again 80a, and 2 power 5 is 32. So this is actually the expansion of a plus 2 raised to the power 5. This is Pascal's triangle. Getting it somehow?
Yes, sir. No.
And then there is definitely practice of this, and it says fully expand the expansion this. So now, but now there is no restriction either using Pascal's or anything else. So we can expand 1 plus 2x cube by simply multiplying it 3 times and then with 1 plus 3x. Question number 5 says expand this, hence or otherwise write down the expansion of this in the ascending power. Let's try this. Now this is 2 plus y cube. And whatever this is the second part of the question. We'll come to it later. This is 2 plus y cube. Now we can actually do it in 3 ways. One is Pascal's triangle, the other is simple multiplication, and the third part is using binomial theorem. Okay, this was, what was that? That was 2 plus y cube. So 2 plus y cube. For now, I will still choose to do it with Pascal's triangle. So you get to see it again and again. So if I write 0, 1, 2, and 3, because my max power is 3, so anything raised to power 0 will be 1. Next, it would be 2 and y only. And the third step, 2 squared. So first number is squared now, plus the last number is squared now. And in between, 2 reduces and y increases. So this is 2 power 1 and y power 1. In the third case, it is 2 cube plus, now 2 will reduce. So it is 2 square and y adds in. Then 2 reduces again and y adds in. And then we have the last term, which is 2 reduces again and y increases up to max power. Now about the coefficients. So coefficient of 2 is 1 here and coefficient of y is 1 here. So 1 plus 1, you see we have to write 2 here. Then coefficient of this 2 squared, is actually 1. 1 plus 2 is 3. Coefficient, these two coefficients, 2 plus 1 is again 3. So now we simplify for our numbers. 2 cube is 8. 2 square is 4. 4 3 times is 12y. And 3 2 times is 6y square. And last is y cube. This was one way. The other is 2 plus y whole cube. We can write it as 2 plus y times 2 plus y cube squared. So 2 plus y, keep it there. A square plus 2ab plus b square. Now we multiply these two. So 2 with all these. 2 4 times is 8. 2 4 times is again 8y. 2 into last is 2y square. Now y with all these 3. Y into 4 is 4y. Y into 4y is 4y square. Y into the last one is y cube. Now we simplify them. First number is 8. Then we have 8y plus 4y is 12y. Then we have y square plus y square is 6y square. And the last number is y cube. Now compare these two. This with this. 8 plus 12y plus 6y square plus y cube. And once we'll move on to the third concept, then we can compare all these three. So in exam, if there is a restriction, just a second, please. Okay, so once we do the third method, we'll be comparing these three. Now, the first part of the question was to expand. And the second part is we've expanded 2 plus y cube, and the second part is 2 plus x minus x square plus 3. Now, what actually this is? We've expanded 2 plus y cube, and then the question is expecting us to solve this thing right here. Are we on the same page?
What is that?
We've done this, and they're now expecting us to solve this. Now you have to compare it. Yes.
So I don't understand the part where we had to expand. Why don't we just use the binomial method?
We can use that, but we have to follow what the examiner will tell you. If he tells you to solve it with Pascal's method, definitely we'll have to do it. So that's why we're doing it. Let me show you. It is actually part of your syllabus by Pascal's theorem. Okay, that's in the drive. This is right here. So you see, use Pascal's triangle relation between binomial coefficients. Not to very much extent, but a little. So you need to have this knowledge. Okay. One is Pascal's, the other is binomial. This formula right here is for binomial expansion. Binomial expansion and Pascal's triangle. We need to know both of these. Okay, now once we've expanded it by using any of the method, so you just compare these two. The 2's are here, and actually this thing is placed in place of y. Do you agree? Do you agree? So you can just substitute this in place of y, that is 8 plus 12, and in place of y you can put x minus x square plus 6. In place of y again, x minus x square whole squared, and in place of y again, x minus x square whole cube. Now we have to simplify this, expand and simplify. So this is 8 plus 12x minus 12x square plus 6. Now this is squared. So a square minus 2ab plus b squared plus, now the cubic term. So I actually haven't never memorized a minus b whole cube. So let me separately solve this. So this is x minus x square whole cube, which will be equal to x minus x square into x minus x square whole square. So that is x minus x square, and this is x square minus 2x cube in plus x4. So x into all these is x cube minus 2x4 plus x5. Then x square into this is minus x4 plus 2x5, and last is minus x6. So we see x cube is only once, then x4 and x4, so minus 3x4, then x5, and x5 is again 3x5, and lastly x6 minus x6. So I'm copying this value here. X cube minus 3x4 plus 3x5 minus x6. And back to basics. So this is 8 plus 12x minus 12x square plus 6x square minus 12x cube plus 6x4, and we open this, plus x cube minus 3x4 plus 3x5 minus x6.
What is
And
happening?
simplification actually. So this is
Okay,
x
hold on.
and there's no other x. So this is 12x. Then we have x square. We have a x square again. Minus 12 plus 6 is minus 6. So this is minus 6x square. Then cube is this and this. So minus 11 x cube. Then x4 is this and this. So this is 3x4. Lastly, 3x5 and x6. We got it? You must have got it.
Somewhat, yes.
Can we do another example?
We can do many examples, but in one class.
Not too many, sadly.
Can we do another one right now?
Yes. Let me find a similar question. Okay. We don't have it right now, but I can create one on my own. A simpler one to compare. For example, let's say the main question is x, or we keep it 3 plus y power 4. The main question is this, and later it tells you to expand 3 plus x minus x square. This. So first part is this, and later it tells you to expand this. That was x cube, and it made a mess. So just for practice, let me make this 2. Just to compare. So first step is expand this small bracket. That is a square plus 2ab plus b square. This is the first part which we did here. That was to expand 2 plus y cube. So 2 plus y cube resulted like this. Then we substituted this new value in this y or in these y. So what we can do right here is, now we know if we compare these two, we know that y is equals to x minus x square. So you can substitute this value and write 9 plus 6 into x minus x square plus x minus x square whole squared. So this was it. Because that was a cube, so it expanded a lot. If it would have been 4, it would expand more. So this is plus 6x minus 6x square plus, now we open this with square. That is a square minus 2ab plus b square. Now we see for the similar terms, 9 is the only number. Then we have only one term which is in x. So 6x. There are two terms which are in x square. So minus 5x square. And then there is only one term in x cube. And the last term, that is x4. First you expand, then you substitute and expand again. So for now, where is it? First thing was Pascal's triangle. To expand using Pascal triangle. Second is yes, binomial expansion. And there are few basic things. How many rows are there? That is always 1 plus part. If this is 15, there are 16 rows or 16 terms in the expansion of final line. Question 4 says fully expand these. So first we expand this cubic part, then we multiply 1 plus 3x with them. Fifth question said expand this part 3, we did, and then we replaced x minus x square in place of y and expanded again. Now look at this. It says the coefficient of x cube in the expansion of this is 45. This is a little same, but in a reverse nature. So let's try this question. This is question 7. And page is 161. So main theme is 2 minus x 3 plus bx cube, and the coefficient of x cube is 45. So this is our question. First we'll expand this, then we'll compare to find the value of b. Now to expand this, 2 minus x, and this is 3 plus bx into 3 plus bx whole square. Please stop me right away where you feel any confusion. So I'm just copying the previous step and expanding this power. So this is a square plus 2ab plus b square. Done. Now I am multiplying these two brackets and copying the first as it is. So now 3 into all these. 3 9 times is 27. 3 6 times is 18 bx. 3 into this is 3b square x square. Now multiplying bx with all these. So b into 9 is 9bx. So 6 stays there. B into b is b squared and x into x is x squared. Third term. B into b square is b cube and x into x square is x cube. Now we've expanded this. Before we multiply these two, I would like to see if we have something in common, and yes, we do have them. So first we'll simplify 2 minus x. Now see this 27, there is no other constant, so 27 comes right away. Now this is 18bx and 9bx. We have something in common, so we'll write 18 plus 9 is 27bx. Now this is b square x square. This is again b square x square. So 3 plus 6 is 9b square x square. And the last is b cube x cube. Now we multiply these two. So 2 into all of these. 2 into 27 is 54. 2 into 27 again 54bx. 2 into 9 is 18b square x square. 2 into this last part is 2b cube x cube. Now we multiply this x with all of these. X into this is minus 27x. X into this is minus 27bx squared. X into this is minus 9b square x cube. And the last one will make it minus b cube x 4. I'm actually interested in only x cube. We would have chosen this before expanding this till here. But because we are just practicing expansion as well, so I did it. I would have ignored this term. You see, 2 into 27 will never give you x cube. Do you agree? So in final exam, we can always skip this part and choose only those values which will give you x cube. So now this is x cube and this is x cube. If I can choose these two, this is plus 2b cube x cube and this is minus 9b square x cube. If I take out x cube, this is 2b cube minus 9b square and x cube as common. Now the main question says that coefficient of x cube is 45. So this coefficient right here must be 45. So 2b cube minus 9b square is equals to 45. You solve for this and you get your answer. So 2b cube minus 9b square minus 45 is equals to 0.
Why is there so much working just for one question?
Yes, that is it. This is the only one topic which will take a lot of effort. Okay. Now there are two main things, three actually. One would be a small expansion of an NCR. The other would be binomial expansions. You've done already binomial expansion in O levels.
No, sir.
No, sir.
So this is the formula. In our next class, once you've practiced it, we will be using binomial expansion. That will make your life easy. Because you just have to plug in the values in your calculator and you'll be fine. So binomial expansion, a plus b, 2 terms. Yes, we only have 2 more things to do. Binomial expansion formula and NCR, only these 2. And we'll be good to go. If there is anything.